In this lecture, we're going to look at the forearm. So we'll start off by looking at the forearm in cross-section. We'll look at the forearm fascia, or the antebrachial fascia, and the various compartments that are formed. We'll then look at these compartments, the anterior compartment and the posterior compartment. And in both of them, we'll look at the various muscles, be it flexor, pronator, or extensor muscles. We'll look at the various layers they form and also the various neurovascular relations. So here we can see a cross-section through the forearm showing the various muscles in their compartments, the interosseous membrane that's running between the two bones, the radius and the ulna. And we can see that with this transverse section, we can divide the forearm into this anterior compartment here and this posterior compartment. Remember, this is the inferior view, and this is a right forearm. So we're looking at it from below. We can see laterally we have the radius, and medially we have the ulna. These two bones are connected from their interosseous borders via the interosseous membrane. Radiating from these bones to the perimeter of the forearm, we have that intermuscular septa. And this is the continuation of the antebrachial fascia from the perimeter into the middle of the arm. So this intermuscular septa running across and the interosseous membrane forms the anterior compartment and the posterior compartment. Here we can also see various blood vessels and nerves, so we can pick up the median nerve, we can see the ulnar nerve and the ulnar artery. We can see the radial artery and the radial nerve as well. And we'll look at these in more detail as we go through this lecture. The anterior compartment contains muscles that are ultimately going to flex the wrist. They're also associated with pronation of the forearm. The posterior compartment contains muscles that are principally going to extend the wrist and also supinate the forearm. But there's also some other movements that can occur. And whilst the majority of the muscles in the forearm act on the elbow, they also act on the radioulnar, the wrist, metacarpophalangeal, and interphalangeal joints. And at these joints, there can be a whole series of movements created by the muscles within the forearm. So these muscles in the forearm can send long tendons that go and attach quite distally to the very distal phalanges of the digits. You can have flexion and extension. This can occur at the elbow joint, at the wrist joint, at the metacarpophalangeal, interphalangeal joints. So most of these joints will enable flexion and extension. At the radioulnar joints, we have pronation and supination, and we'll look at some important muscles that do that. And also at the wrist joint and at the metacarpophalangeal joints, we can have adduction and abduction. So let's start off by looking at muscles in this anterior compartment. Now, there is a warning. There is a lot of muscles here. There are a lot of muscles in this anterior compartment of the forearm. But conveniently, they have been split up into various layers. And we can look at these layers individually and the muscles that lie within each of these three layers. A superficial, a middle, and then a deep layer. And we'll look at these layers individually. So first of all, we'll start with the superficial layer. We can see here in this superficial layer, we have pronator teres, we have flexor carpi radialis, we have palmaris longus, and we have flexor carpi ulnaris. These are all coming from a common origin, so they're originating from a very similar place, this being the medial epicondyle. There can be some slight variations to where all of these muscles come from, but the main common origin is this medial epicondyle here. And we can see they're radiating across the elbow joint and attaching to various places on the forearm and also in the hand. So we can see pronator teres is running across to the radius. We can see flexor carpi radialis is running towards the second metacarpal. We can see palmaris longus is running towards the palm of the hand. And we can see flexor carpi ulnaris here is running towards one of the carpal bones. So let's look at this in more detail. We can see in the superficial layer we have pronator teres, flexor carpi radialis, palmaris longus, and flexor carpi ulnaris. If we look at pronator teres, we've got two heads of pronator teres because they have a different origin. An ulnar head coming from the coronoid process of the ulna, and a humeral head, which is coming from that medial epicondyle. This is why it's important to have those bony attachments, those bony landmarks from the osteology lecture previously. The pronator teres muscle is going to insert onto the middle of the lateral surface of the radius. So if we go back, we can see that pronator teres coming from the medial epicondyle and also coming from the ulna, its ulnar head is passing towards the shaft of the radius. We can see it here. We then remind ourselves flexor carpi radialis, palmaris longus, flexor carpi ulnaris, and we can look at their attachments. Flexor carpi radialis and palmaris longus are coming from the medial epicondyle of the humerus. So both of these are coming from the medial epicondyle of the humerus. As we saw, the flexor carpi radialis attaches to the base of the second metacarpal, whereas palmaris longus passes towards the palm of the hand and attaches to what's known as the palmar aponeurosis and the flexor retinaculum. And we'll look at these as we pass towards the hand in next lecture. All of these muscles, pronator teres, flexor carpi radialis, palmaris longus, are supplied by the median nerve. The one muscle in the superficial layer they're supplied by the ulnar nerve is flexor carpi ulnaris, and this lied most laterally, and this was positioned most medially within the forearm. It originates from the olecranon and the posterior surface of the ulna, and it passes to a range of bony landmarks, the pisiform and the hook of the hamate, also the fifth metacarpal. So flexor carpi ulnaris is passing to these, inserting to these bony landmarks. It's different from the other superficial muscles in this compartment in that it's innervated via the ulnar nerve. If we look at the function of these muscles, well, pronator teres, its name gives it away, it pronates the forearm. It can also, because it crosses over the elbow joint, flex the forearm. Flexor carpi radialis is important at flexing the wrist. It also, because it's on this lateral aspect, contraction can abduct the hand at the wrist joint. Palmaris longus, this flexes the hand at the wrist. It also tenses the palmar aponeurosis. The palmar aponeurosis being a tough, fibrous tissue in the palm of the hand, and tensing this is important when forming a grip. Flexor carpi ulnaris is very similar to flexor carpi radialis in that it flexes the wrist, but as it's running down this medial side, it also adducts the wrist, or it deviates it to the ulnar side. So now if we go back and have a look at the middle layer, then there really is only one muscle that I really want to talk about in this middle layer, and that is flexor digitorum superficialis. Flexor digitorum superficialis, as its name suggests, is a flexor of the digits. As we call it flexor digitorum superficialis, it means that there's going to be a flexor digitorum profundus, and we can see that on this picture here. But we're just concentrating on flexor digitorum superficialis. We can see that its long tendons pass all the way to the middle phalanx of the digits. We can see that here. If we have a look at the attachments of those muscles, we can see flexor digitorum superficialis. It's got two heads. It's got a humero-ulnar head, and this head is coming from the medial epicondyle. It's coming from the coronoid process as well, and that's where we have the humero-ulnar head. It has a part coming from the humerus, the medial epicondyle, and a part coming from the ulna, the coronoid process. It also has a radial head, and it's coming from the shaft of the radius. So the flexor digitorum is coming from a whole wide range of regions from the humerus, the ulna, and the radius. This muscle belly eventually is going to give rise to long tendons that go and attach to the middle phalanges of the medial four digits. So they're all the digits but not including the thumb. So digits 2, 3, 4, and 5. It's supplied by the median nerve. The nerve supplied to flexor digitorum superficialis is the median nerve. Importantly, it flexes the hand at the wrist joint. It also flexes the proximal interphalangeal joint. That's the joint between the proximal and the middle phalanges, the proximal interphalangeal joint. With continued action, it will flex the proximal phalanges at the metacarpophalangeal joint. So ultimately, it helps us to form a fist. Helps us to form a fist. If we then look at the deep layer, we can see we've got some muscles which are lying deep to flexor digitorum superficialis. We have flexor digitorum profundus. We can see that this is coming from the ulna. It's also coming from the interosseous membrane that's between the two bones of the forearm, the radius and the ulna. And this again gives rise to 4 long tendons that this time go towards the distal phalanx of each digit 2 to 5, not including the thumb. The thumb is different because it has its own specific flexor, and this is known as flexor pollicis longus, pollicis meaning the thumb. Flexor pollicis longus. The fact that we call it flexor pollicis longus indicates there's going to be a flexor pollicis brevis, and this muscle is within the hand, so we'll look at it later. The final muscle, the deep muscle in the anterior compartment, is pronator quadratus, and that runs between the 2 distal ends of the radius and the ulna. So let's have a look at the attachments of these muscles. Flexor digitorum profundus is running from the proximal surfaces of the medial and anterior surfaces of ulna and the interosseous membrane. So it's coming from the ulna. It then passes via its 4 long tendons to the distal phalanges, the medial 4 distal phalanges of digits 2, 3, 4, and 5. The nerve supply, it has a dual nerve supply. The lateral muscle bellies, these are the ones that are going to digits 2 and 3, are supplied by the median nerve, and the tendons that are going to digits 4 and 5 are supplied by the ulnar nerve. So flexor digitorum profundus has 2 nerves supplying it, the median nerve and the ulnar nerve. Its function is to flex the hand at the wrist joint, and it also flexes the distal interphalangeal joint. So where flexor digitorum superficialis flexed the proximal interphalangeal joint, this now flexes the very distal interphalangeal joint, the joint between the distal phalanx and the middle phalanx. If we go back and look at flexor pollicis longus, we can see this is really coming from the radius, and this gives a long tendon that goes and attaches to the distal phalanx of the thumb. So we can see that flexor pollicis longus, running from the anterior surface of the radius and also the interosseous membrane, passes to the distal phalanx of the first digit being your thumb. The pronator quadratus, as we saw here, is running between the 2 distal ends of the radius and the ulna. It runs from the distal quarter of the ulna, so the last quarter of the ulna, and it actually passes towards the radius. So when pronator quadratus contracts, it is actually going to move the radius. It is going to move the radius into a more pronated position. So from this supine position, contraction of pronator quadratus is going to pronate the radius, pronate the forearm, which pulls the radius over the ulnar bone. Both flexor pollicis longus and pronator quadratus are innervated via the anterior interosseous nerve. And this is a branch of the median nerve. So the median nerve is supplying the majority of these muscles within the anterior compartment, but a specific branch, the anterior interosseous nerve, is supplying the flexor pollicis longus and pronator quadratus. Flexor pollicis longus does similar functions to flexor digitorum muscles, except it acts at the first digit. Continued contraction will flex the wrist. It flexes the interphalangeal and metacarpophalangeal joints associated with the first digit. Pronator quadratus pronates the forearm. So it acts on the radio-ulnar joints. Here we can look at the anatomy with all of these muscles put together, and we can see the actual region of the forearm is quite complicated with all of these muscles. And here we're just looking at the superficial and the middle layers. We can see on this superficial layer, we have those muscles, pronator teres, flexor carpi radialis, palmaris longus, and flexor carpi ulnaris. We can see they're all radiating away from this medial epicondyle region, and they're passing across the forearm. So we can see pronator teres here. We can see flexor carpi radialis, and then giving rise to its long tendon. We can see palmaris longus that's passing down here towards the palm. And then we can see flexor carpi ulnaris on this most medial aspect running down here. So this is in the superficial layer. We can also see in this middle layer, we have flexor digitorum superficialis. Flexor digitorum superficialis lies deep to this superficial layer. So to see that, we've just cut away a piece of flexor carpi radialis here. We can see a bit more of pronator teres running around here. And we've just reflected this muscle, brachioradialis. So we've cut through flexor carpi radialis, we've cut through palmaris longus. And underneath, we can see this large muscle belly, which is flexor digitorum superficialis. We can see here we've got its radial head, and here we've got its humero-ulnar head. Remember, flexor digitorum superficialis originated from the radius, the ulnar, and the humerus. And we can see all of those heads. Ultimately, it was giving rise to muscle bellies, was giving rise to 4 tendons that went to digits 2, 3, 4, and 5. So, as these muscles pass towards the wrist, they are held in position by the flexor retinaculum. The flexor retinaculum is a really important structure in that it prevents bowstringing of these tendons. So it's held in position by the flexor retinaculum and also the palmar carpal ligament. And we'll see these when we move into the hand. Although brachioradialis, which is a muscle we can see being reflected here, this muscle also flexes the elbow. So although brachioradialis flexes the elbow, which is similar to what these muscles do, it is actually within the posterior compartment. And it's in the posterior compartment because it's supplied by the radial nerve. So although we can see that muscles in the anterior compartment flex the elbow, brachioradialis, although it flexes the elbow, is in the posterior compartment because of its nerve supply. The brachioradialis muscle is supplied by the radial nerve, and therefore is known to be in the extensor compartment. We'll come back to it in the next slide. If we look at the deep layers of the anterior compartment, then here we can just see the middle layers once again, with these muscles having been cut and brachioradialis reflected. What we've done now is we've cut through flexor digitorum superficialis. So here is flexor digitorum superficialis, and on this side of the screen, we can see that we've cut through it. This is flexor digitorum superficialis being cut, and what we can see is flexor digitorum profundus. Here, deep to flexor digitorum superficialis, we can see flexor digitorum profundus. We can see we also have flexor pollicis longus. So flexor pollicis longus is running in this direction. We can see it's coming from the radius. And also deep in here, we can just make out pronator quadratus, the deepest of the muscles. But what we can see here, these cut tendons, these are the cut tendons of flexor digitorum superficialis. And deep to them, we can see now the tendons of flexor digitorum profundus. Remembering that flexor digitorum profundus had that dual nerve supply. The medial muscles, the medial tendons were innervated via the median nerve, so 2 and 3, and tendons to digits 4 and 5 were innervated via the ulnar nerve. So here we can see it quite deep. So now let's move on to the posterior compartment. And the posterior compartment is going to contain muscles that essentially extend the wrist. But first of all, we can see in this posterior compartment brachioradialis. Brachioradialis, as I just mentioned, was that muscle that can also flex the elbow. But it's in the posterior compartment due to its nerve supply, being supplied by the radial nerve. So here we can see brachioradialis. We can then see two muscles, and these are known as extensor carpi radialis. We have a longus version and we have a brevis version. And these are coming from the humerus and they're coming from the lateral epicondyle, as we'll see. So we can see that brachioradialis, extensor carpi radialis longus, and extensor carpi radialis brevis. Here we can see their attachment sites. Brachioradialis is coming from the proximal 2/3 of the lateral supracondylar ridge. So here we'd have the lateral supracondylar ridge. That's where brachioradialis is coming from. And it passes to the lateral surface of the distal radius. So it just crosses the elbow. It doesn't cross the wrist. It passes to the lateral surface of the distal radius and the pre-styloid process. So just a small elevation before the styloid process. It's innervated via the radial nerve, and it's a weak flexor of the elbow. It's a strong flexor, however, when the forearm is mid-pronated. So if the elbow is fully supinated like this, it's a very weak flexor. But in this mid-pronated position, it is a very strong flexor of the elbow joint. So a really important muscle, brachioradialis. If we then look at the two muscles slightly deeper, we have extensor carpi radialis longus, we have extensor carpi radialis brevis. We can see that these two muscles, also coming from the lateral supracondylar ridge, extensor carpi radialis, and extensor carpi radialis brevis is coming from the lateral epicondyle. So we can see that they gradually work their way down the humerus, from the lateral supracondylar ridge all the way down to the lateral epicondyle. Extensor carpi radialis longus attaches to the second metacarpal. Extensor carpi radialis brevis attaches to the third metacarpal. And again, we can see that here, attaching to the second metacarpal and attaching to the third metacarpal. Extensor carpi radialis longus attaching to the second, brevis attaching to the third. We can see these two muscles are supplied by the radial nerve, extensor carpi radialis longus by the radial nerve itself, extensor carpi radialis brevis via the deep branch of the radial nerve. And these two muscles help to extend and abduct or radially deviate the wrist to the radial aspect, abduct the wrist. If we look at the superficial layers, if we carry on looking at the superficial layer of the posterior compartment, then we can see we have three more muscles here. We have extensor digitorum, we have extensor digiti minimi, and we have extensor carpi ulnaris. And these muscles, again, are passing from this lateral epicondyle, and they're running all the way down to the digits of the hand. So here, if we see extensor digitorum and extensor digiti minimi coming from the lateral epicondyle of the humerus, and these pass towards the digits. Now, unlike the flexor compartments, these extensor muscles don't kind of physically attach to the distal or the middle or the proximal phalanges of the digits, but they attach to a connective tissue fibrous band over each of the digits known as the extensor expansion. And this is a sheath that surrounds the interphalangeal joints of the digits. So here we can see that extensor digitorum is attaching to the extensor expansion of the medial four digits, and extensor digiti minimi is going specifically to the extensor expansion of the fifth digit. These two muscles are supplied by the posterior interosseous nerve, and this is coming from the deep radial nerve. They're both associated with extending the wrist. They extend the medial 4 digits if you're extensor digitorum, and the 5th digit for extensor digiti minimi. They extend the digits at the metacarpophalangeal and interphalangeal joints, and they do this by attaching to those extensor expansions. If we look at extensor carpi ulnaris, then extensor carpi ulnaris is running down again from the common extensor origin, or at least near to the common extensor origin, specifically the lateral epicondyle. It also is coming from the posterior surface of the ulna. This passes to the dorsal aspect of the 5th metacarpal associated with the little finger. And again, this is supplied by the posterior interosseous nerve. This muscle is associated with extending the wrist, just like the previous muscles. It's also associated with adducting the wrist. And extensor carpi ulnaris can work with flexor carpi ulnaris to adduct the wrist. If we now move on to some deep muscles on the posterior compartment, also known as these outcropping muscles, then we can see we have a whole series of them. Abductor pollicis longus, extensor pollicis longus, extensor pollicis brevis, and extensor indicis. Now these muscles are passing specifically to the thumb, the pollicis muscles, and to the index finger, extensor indicis. So these are passing from the forearm, going across the wrist, and attaching to features on digits 1 and 2. So if we look at abductor pollicis longus, we can see here is passing all the way to the metacarpal of the 1st digit. It's coming from the posterior surface of the radius and the ulna, and also the interosseous membrane, so it has a widespread origin, and it inserts at the metacarpal of the 1st digit. Extensor pollicis longus specifically passes from the posterior surface of the ulna and also the interosseous membrane, so not the radius this time, and it passes to the dorsal surface of the distal phalanx of the 1st digit, so the distal phalanx of your thumb. Extensor pollicis brevis, the posterior surface of the radius and interosseous membrane, and it passes to the dorsal surface of the proximal phalanx of the 1st digit. So here we have extensor pollicis longus passing to the distal phalanx, and extensor pollicis brevis passing to the proximal phalanx. And this is where they get their names longus and brevis. Longus, the longer of the muscle, passes most distally to the distal phalanx, and brevis, the shorter of the muscles, passing to the proximal phalanx. All of these muscles are supplied by the posterior interosseous nerve. This originates from the deep radial nerve, and we can see they have quite a widespread function. Abductor pollicis longus extends the wrist because it crosses the wrist joint, and it works on the thumb. It abducts the thumb and extends it at the carpo-metacarpal joint. Extensor pollicis longus and extensor pollicis brevis are going to work to extend the wrist, extend the distal and proximal phalanx of the thumb at the interphalangeal joints, and also extend the metacarpophalangeal and carpo-metacarpal joints. So we can see we have widespread function of these muscles. Here we can also see that we have what's known as supinator muscle. We can see here, and supinator muscles, as its name suggests, is going to supinate the forearm. We can see that supinator is running from the lateral epicondyle of the humerus. We can see here it's running from the lateral epicondyle of the humerus. It's also running from the supinator fossa on the proximal ulna, so a specific region on the ulna, and it passes to the posterior, lateral, and anterior surfaces of the proximal radius. Supplied by the deep branch of the radial nerve, and as its name suggests, it's going to supinate the forearm. Finally, we can just see extensor indices. Extensor indices is important as it passes specifically to the index finger, giving the index finger some specific functionality. Extensor indices is coming from the posterior surface of the ulna and also the interosseous membrane, and it passes to the extensor expansion specifically of the second digit, your index finger. It's supplied by the posterior interosseous nerve. Again, this is coming from the deep radial nerve, and it serves to extend the wrist and extend the second digit. It can do this independently from extensor digitorum, so the index finger is allowed to have some independent function. So here we can see the anatomy of the posterior aspect of the forearm. We can see this is a right forearm, and we have a lot of the muscles all put together in their proper anatomical position. So we can see most distally a whole series of tendons, and these tendons are coming from the muscles on the posterior surface. And here we have the extensor retinaculum. So most distally we have the extensor retinaculum, and that prevents bowstringing when the hand is extended. When the hand is fully extended, you don't want these tendons from splaying either side, and the extensor retinaculum prevents that. Divided into superficial and deep layers, the muscles in the posterior compartment, the tendons pass over the wrist, and they're covered in what are known as synovial sheaths. These synovial sheaths prevent friction as the tendons run over the wrist, and they create these osseous tunnels formed by the extensor retinaculum, and they help to prevent friction. So you have these synovial sheaths that prevent excess friction as the tendons are trapped between the bones of the wrist and the extensor retinaculum. And these synovial sheaths prevent that excess friction. The tendons of the extensor digitorum flatten, as I mentioned previously, and form these extensor expansions. These are tendinous aponeuroses that pass over the dorsum and sides of metacarpal and the proximal phalanx of each digit. So instead of attaching directly to a phalanx, a distal, a middle, or a proximal, they blend with this tendinous aponeurosis that lies on the dorsum and the sides of the metacarpals and proximal phalanges, so that the tendons actually just blend with this aponeurosis. It means that you actually lose extensor function. Unlike the flexor compartment, where the muscles and the tendons inserted directly onto bony points, you had a lot more flexion control. For extension, you don't have that level of control because of this widespread insertion into the extensor expansions. So if we dig a bit deeper and remove some of these middle and superficial layers, we can actually see the deeper muscles. Here we can see the tendons of extensor digitorum have been cut away, so we can look into this deep aspect. We can see abductor pollicis longus here. We can see extensor pollicis longus, extensor indicis. We can see these outcropping muscles as well. Extensor pollicis brevis is one of them. And these are passing out, going across the wrist and heading towards the thumb, and for extensor indicis, the index finger. Now this forms a very specific region at the wrist known as the anatomical snuff box. Anatomical snuff box. So passing laterally towards digits 1 and 2 are these outcropping muscles. They come from deep and they pass outwards, out onto this lateral aspect heading towards digits 1 and 2. And here are those muscles that I mentioned. The tendons of extensor pollicis longus, the tendons of extensor pollicis longus medially, and extensor pollicis brevis and abductor pollicis longus laterally form the anatomical snuff box. So here we've got the 5th digit, so this is medially. We can see we have extensor pollicis longus. So if we follow this all the way around, we can see that we're forming this medial boundary here. If we then look laterally, we can see we have 2 tendons. We have extensor pollicis brevis, and we have the tendon of abductor pollicis longus. And here we can see a small little region, this triangular region known as the anatomical snuff box. It's located on the lateral surface of the wrist, bound by these tendons. You can also observe that the index finger receives a specific muscle, and this is very separate and distinct to extensor digitorum, and this is extensor indicis. We'll come back to the anatomical snuff box when we look at the dorsum of the hand. So if we then look at the posterior compartment, we can appreciate some important nerves which are located here. Most of these arteries are going to be a direct continuation of the brachial artery. So here we can see we have various tributaries running along the posterior compartment. So we can see the posterior interosseous artery, and that's coming from the radial artery. And then we can see here we've got the radial nerve that's passing into the posterior compartment to supply all of these muscles. They're running in the posterior compartment. So in this lecture, we've looked at the forearm in cross-section. We've looked at the antebrachial fascia and the compartments that it forms. We then looked at a whole series of muscles in the anterior compartment, and we looked at their relations to one another within the anterior compartment. And then we looked at the posterior compartment. We looked at the extensor muscles, where again we looked at a whole series of muscles, and then briefly at the end we looked at the neurovascular relations. We'll look at the neurovascular relations in more detail when we look at the overview of the blood supply to the upper limb as a whole, and that's in a later lecture.